This is section 822. We're going to look at coordinate trigonometry. So we're going to find all 6 trig ratios from a coordinate and then find the trig ratios from a ratio and some restrictions. Now, as a reminder, we talked about reference angles, right? And we said that an angle that is in standard position, the reference angle is going to be the acute angle formed by the terminal side and the horizontal axis. So just a real quick reminder, let's just say if my angle was 262 degrees, how do I find this reference angle, which is the angle right here? It's from the terminal side to the horizontal axis. I need to know what that angle is going to be. And so what I can do is we kind of have to piece it together, and in that piecing together, because I know that that right there is 180 degrees, what I can do is I can just subtract it out and I can find what that missing angle is. Now the interesting thing here is I can actually turn this into a triangle. And so this being the point on my radius, and then this is my y value and this is my x value, right? Because it goes along the x-axis and one goes along the y-axis. And so we're actually going to be using this idea of creating these reference triangles in pretty much the rest of this chapter. And we can do it in radians as well, right? So if I knew that that was 4 pi radians, right, what the question is, well, what's this? You can construct a triangle, and then from there, what's missing is going to be, if I know the entire thing is pi, find the common denominator, 5 pi fifths. So that means what's left is going to be a pi fifths. Right? We're just finding reference angles, but we're going to do the majority of our stuff in angles. We're not going to really do too much in radians. We're going to do a lot of it in angles, or in degrees, sorry. So let's take a look at how does sine and cosine and tangent and its reciprocals, how does all that relate to this coordinate? So if I draw a coordinate, x and y, what we're able to do is we're able to actually go through and create this reference triangle. Now, this reference triangle is always perpendicular to the x-axis. Always perpendicular to the x-axis. So the x is always along the x. We don't draw the y on the y-axis. Right? That's another way of thinking of it. It won't be. It has to be perpendicular to the x when we draw it, every single time. But now what that means is, because I know this is my y coordinate and this is my x coordinate, sine is opposite over hypotenuse. Opposite is my y, so y over r. My cosine is adjacent over hypotenuse, or x over r. My tangent is opposite over adjacent, or y over x. Cosecant is the reciprocal of sine, so you flip it, r over y. Secant is the reciprocal of cosine, so you flip it. And then cotangent is the reciprocal of tangent, and so you're going to flip the ratio. And this all pertains to this particular rotation, right? So this rotation here yielded me those particular values. And then to find the radius, it's just the Pythagorean theorem, or you just take the square root of the 2 coordinates squared. So find the 6 trig functions of theta if the given point on the terminal side of thing. Okay, so here's an actual coordinate. So 1, 2, 3, 4, 1, 2, 3. So that means here's my radius. Draw the triangle perpendicular to the x-axis. Now what does that mean? Okay, well, this distance here is 4. That's my x. And then this distance is going to be 3. That's my y. To find my radius, Pythagorean theorem. So that's going to be 5. So now that I have those values, I can just, we know that this right here is theta. That's my rotation. So I can say the sine of theta equals opposite over hypotenuse, or y over r. The cosine theta equals adjacent over hypotenuse, so 4 over 5, or x over r. This tangent of theta equals opposite over adjacent, or y over x. And then the reciprocals. So cosecant S goes to C goes to S. All I have to do is just flip it. Secant, just flip it. And then the cotangent, just flip it. There's our answer. Looking at one more, -5, -5. 1, 2, 3, 4, 5. Okay, so it's all the way down here. Right, perpendicular to the x-axis. I know that this is -5. I know that this is -5. And then so c squared equals -5 squared plus -5 squared. Should put parentheses there. So that's 25 plus 25. So c is going to equal, was it 2? Sorry, root 2 times 5, which is 5 root 2. So I know that this is going to be 5 root 2. So now, even though that's my rotation theta, right, this is the reference angle. So that's the reference angle that we're talking about. So my sine of theta equals opposite over hypotenuse. Opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. The tangent of theta equals opposite over adjacent, which is 1. And then the reciprocals. So cosecant, flip it, secant theta, flip it, and then cotangent theta, 1. So a pattern that we should have gotten from this is going to be that x and y, they kind of relate to these sines and cosines. X relates to cosine, sine relates to y. So when x is positive, cosine is positive. When x is negative, cosine is negative. We saw this from this previous one here, right? My y was negative, so is my sine. My cosine was negative, so is my cosine. So when your y or x is positive, the sine or cosine is going to be positive, and the same goes for it to be negative. Now, having said that, it goes along with these different quadrants. So we can assume, right, that we have these different positives and negatives depending on what the quadrant's in. Now, it's much better just to memorize or know this statement here. Cosine is x, y is sine. So wherever your sine is positive, so is your y. Or wherever your y is positive, so is your sine. Wherever your x is negative, so is your cosine. It's much easier to think of it that way. So let's look at a few of these. This is what I mean. So it's saying sine is less than 0, cosine of theta is less than 0, okay? Well, if I know that this is going to be y and this is going to be x, where's my x and y negative, right? Less than 0 is negative, it's negative. I don't know why I put the 1 there, but it's just negative. So where are they both negative? That's going to be in this quadrant, so that's quadrant 3. Where is my sine positive? Okay, so my sine is positive, so my y is positive here. And it's saying, where is my tangent negative? Okay, so tangent, we said, is y over x. Well, if that means one of them is negative and one of them is positive for it to be negative. So those are going to be in those quadrants because one of them is positive, one of them is negative. Where do they intersect? That's quadrant number 2. And then my sine is less than 0, my secant is greater than. Okay, so this is sine is relates to y, secant relates to cosine, cosine relates to x. So where is my y negative and my x positive? Okay, so we look at so my y is negative here, my x is positive here. Where do they overlap? Quadrant 4. And then my cotangent, okay, so that's going to be x over y. One of them is negative. And my cosecant, that's why it's positive. So my y is positive. My cotangent, one of them is negative. Okay, where do they overlap? It's going to be quadrant 2. Now, we can just use that information to help us. So let's look at this example here. Given sine of theta is 15 over 17, and my secant of theta is less than 0. Okay, so my secant, which relates to cosine, cosine relates to x. I know my x is negative. My sine, it says my ratio is positive, so my y is positive. So my y is positive here. My secant is negative here, so that means it's going to be in quadrant 2. So that's where I'm going to draw my reference triangle. So you're going to draw it in quadrant 2 and you're going to label it. We know that this is opposite over hypotenuse. So if this is my reference angle, opposite over hypotenuse. Use the Pythagorean theorem. We can get that that's going to be negative 8, right? A squared plus b squared equals c squared. And so then you can use that to find your cosine theta, adjacent over hypotenuse. Now, because we're in this realm of, things can be positive or negative, that's why I wrote in negative 8 here, because I'm going negative along the x-axis. So cosine is adjacent over hypotenuse. That's where I get my cosine theta is negative 8 over 17. So I figured out which quadrant the reference angle is, right? That was the positive and negative. I drew the triangle in that quadrant, and then I found the ratio. Let's look at this next one. Cosine of theta is 2 root 2 over 3, and my cosecant theta is less than 0. So cosine theta is 2 root 2 over 3. So I know that my x, this ratio is positive, so my x is positive. Cosecant relates to sine. Sine relates to y. My y is less than 0, so it's negative. So I need to think about where that's going to be. My y is negative here. My x is positive here. So that's going to be quadrant number 4. So we draw my reference triangle in quadrant number 4, perpendicular to the x-axis. This is cosine, so this is adjacent over hypotenuse. So if this is my theta, this is my adjacent, this is my hypotenuse. So now Pythagorean theorem, a squared plus b squared equals c squared. Right? I don't know what this is going to be, and so I need to figure it out, minus 1. Okay, so I get that is going to be plus or minus 1. Now, there's direction. We said that this is negative, so that means I'm going to say it's negative 1 because it's in quadrant 4 and it's moving in the negative direction. So then it says find sine theta. Okay, sine theta is opposite over hypotenuse, and so it's going to be negative 1/3. So what did we learn today? We talked about taking coordinates, putting them on sine or cosine, and figuring what those values are. So cosine relates to which coordinate? It's going to relate to the x coordinate, and sine relates to the y coordinate. This does conclude our lesson. If you have any other questions, please leave them in the comments.